World's most dangerous tunnel. Engineers almost gave up. When the engineering team started digging the tunnel, at one point, water hidden inside the mountain started filling the tunnel with jet-like pressure, creating a flood-like situation. The Gotthard Base Tunnel in Switzerland is also called the Mount Everest of the engineering world. With a length of 57 kilometers, it is not only the longest tunnel in the world, but also the deepest, built at a depth of 5 kilometers. Why had this tunnel become a necessity for all of Europe? How did the engineering team solve the problems of falling rocks inside the mountain, fast-flowing water, and the window-shattering air pressure from the trains passing through it? Welcome back to OGEM TV videos, viewers. If you look closely at the map of Europe, there is a wall of mountains standing in its middle that has created barriers for trade and travel for years. This wall of mountains is called the Alps. For centuries, people traveled over them on long zigzag routes, but sometimes snow, sometimes avalanches, would quickly block the way. Bridges were built on these mountains. Railway tracks were also extended, but climbing steep hills with a train was also very difficult and time-consuming. After that, another major problem arose over time. To boost Europe's economy and send more goods from one country to another, these zigzag routes were no longer sufficient. The factories of Northern Europe and the seaports of Southern Europe both depended on each other. To solve this problem, engineers had only two options: either build more difficult and wider roads over the mountains, or do something that had been considered impossible for centuries. They decided that they would not go over the mountain but dig a tunnel right through the middle of it. A tunnel that would be the longest and deepest in the world. But this mission, as easy as it sounds, was equally terrifying in reality. So deep underground that the weight of the mountain could tear any steel wall like paper. The engineers knew that their battle was not just against soil and rocks, but against the forces of nature that no one had ever challenged before. The construction of the Gotthard Base Tunnel was no ordinary construction. Its biggest enemy was extreme pressure, because the tunnel had to be dug under a 2,500-meter high mountain. That meant that millions and billions of tons of mountain weight would constantly press on the tunnel walls. To experience this pressure, engineers first tried digging a small tunnel, but the mountain's pressure tried to close the tunnel back up. But that was just the beginning. The second big challenge was extreme heat. At such depths, whether in the ground or a mountain, temperatures easily reach 50 degrees Celsius. In such heat, a person cannot work for more than 15 to 20 minutes, and if the cooling system fails, this tunnel could become a living grave for the workers. After pressure and heat, the most terrifying enemy for the engineering team was water pressure. This was no ordinary underground water. It was pressure hidden for centuries that, if suddenly released, could tear through a concrete wall like a cannonball. These were the reasons why famous engineers around the world had clearly stated that this tunnel could simply not be built. They said that in such a long and hot tunnel, machines would break down, so how could workers possibly survive? Furthermore, the tunnels dug from both sides would be dug over a distance of 57 kilometers. If there was even a 1 millimeter difference in alignment, both teams would get lost in the darkness of the mountain, and billions of dollars would go to waste. But for Switzerland, this wasn't just a project. It was a matter of survival. Thousands of trucks passed through the Alps every year. Pollution was increasing, and the roads had exceeded their limits. If this tunnel was not built now, the entire European trade system would collapse. Switzerland decided that no matter the cost, this would become the world's greatest marvel. Now, the question wasn't whether the tunnel would be built. The question was how to face these challenges. On September 27, 1992, this project was officially approved. This was no ordinary tunnel. Its scale was beyond the limits of human imagination. The total length of the Gotthard Base Tunnel was set at 57 kilometers. That's like Delhi to Ghaziabad, or Lahore to Kasur. Such a long distance. That too, 5 kilometers inside a mountain. But in the world of engineering, length isn't just a number. It indicates the intensity of the challenge. The rule was, the longer the tunnel, the higher the risk of error. Engineers had to start digging from both sides of the mountain, and both tunnels had to meet exactly at the center of the 57 kilometers. If the calculation was off by even 1 centimeter, the two tunnels would never meet. To solve this difficulty, laser navigation and GPS technology were used to calculate exactly where to make the opening on both sides. To make the impossible possible, the world's greatest tunnel boring machines were built. These machines were so large that their cutter head was taller than a 2-story house. In terms of total length, this TBM, named Sissy, was 450 meters long, almost half a kilometer. But despite having such enormous machines, they were cutting only a few meters of the mountain per day. These weren't just machines. They were a test of patience for the engineers, a test that would last for the next 17 years. But alongside this, another battle was being fought, the Battle of the Excavated Rock. During the excavation of the Gotthard Base Tunnel, approximately 30 million tons of debris were removed from the mountain. This was so much debris that if piled in one place, it could form an entire new mountain. Hundreds of trucks worked day and night just to remove this debris. Thousands of workers descended into the depths of the earth every day, where there was no day or night, no phone signal, no fresh air. There was only the noise of machines, the damp smell of earth, and an underground world where 2,600 workers lived and worked at a time. But soon, the engineers realized that their real enemy wasn't the length of the tunnel. When the excavation reached the depths of the mountain, the engineers faced an enemy they had expected, but were not prepared for. 2 kilometers below the surface, the mountain rocks radiate their heat. As the machines advanced, the temperature began to cross limits. First 30, then 40, and finally 50 degrees Celsius. This was no longer a construction site. It had become an oven. In the early days of the Gotthard Base Tunnel, when workers descended, they would be drenched in sweat within minutes. Machine operators were given shifts of only 2 to 3 hours. Otherwise, the risk of heat stroke increased. To solve this problem, cooling pipes were laid, through which cold water was circulated from outside the tunnel. This was the world's first construction site where the environment was created for the workers first, and then construction began. Slowly, they realized that the heat problem was just the beginning. The real terror was the pressure of the mountain, which tested them at every step. Cracks in the rocks, sudden collapses of rock. This had become a daily occurrence. To solve this problem, workers would immediately spray a concrete mixture on that area. At some places, precast concrete slabs were installed, and at others, steel rings were used to create an artificial skeleton. This provided support to the weak rocks inside. Now, a solution for falling weak rocks had been found. But ahead, the engineers faced a danger that wasn't solid like rock but liquid. Water. During boring, a time came when a flood of water burst out from inside the mountains. Inside mountains, the variety of rock is not uniform. Some rocks are extremely hard, while others are very soft. And just as there are underground water reservoirs, water is also stored inside the cracks of mountains. And because this water is under the burden of the mountains, its pressure can reach up to 2,900 psi. That's like placing the weight of a car on just 1 inch. There was only one way to solve this difficulty: convert the water into solid form. For this, before boring, small pipes were drilled and freezing liquid was circulated through them. This process continued for several weeks, and finally, the mountain water froze and became solid. Now, when the TBM bored here, the frozen water would remain stable like normal rock. After boring through the water section, concrete lining was installed, and then the freezer was turned off. But the engineers also did one more thing. They left collection points between the concrete slabs and the mountain for water to pass through, so that the water wouldn't put pressure on the tunnel walls later, but could instead flow out of the tunnel easily. After this final obstacle, only one thing remained: the moment when the two ends of the tunnel would meet. On October 15, 2010, the whole world's eyes were on Switzerland, 2,500 meters below the ground, inside the heart of the mountain. The teams coming from both sides were now only a thin wall apart. Everyone had the same question: would 17 years of hard work pay off? Or would this become a 57-kilometer-long grave costing billions of dollars? Suddenly, the joint cutter head of the Sissy machine broke through the final wall. This moment was historic for all of Europe. When the calculations were checked, the difference between the two tunnels was only half an inch. This was accuracy like threading a needle from 50 kilometers away. By now, you might be thinking that stone and water were the biggest enemies. But in reality, the biggest enemy was the air inside the tunnel. After construction was complete, when a high-speed train enters the Gotthard Base Tunnel at high speed, the air inside would have no way to escape. This would create a shockwave that would shatter the train's windows with a blast. Fortunately, this problem had already been anticipated. For this reason, not one but two tunnels were built. After every few meters, a connecting passage was built between the two tunnels, and some ventilation shafts were also built to give the shockwave created by the passing train a way to escape. But imagine if this invisible force hadn't been thought of in advance. 17 years of hard work and billions of dollars would have gone to waste. The idea for the Gotthard Base Tunnel was first proposed in 1940. but due to engineering challenges, work began in 1993. Its construction took 17 years of time, the blood and sweat of 2,600 workers, and a cost of $12.5 billion. Above it, the height of the mountain is equal to the height of 3 Burj Khalifas. To keep the tunnels coming from both sides aligned straight, GPS, gyroscopes, and laser navigation were used. The Gotthard Base Tunnel is so long that it was calculated according to the Earth's curvature. The debris removed during the tunnel excavation, if shaped, could have built 5 Great Pyramids of Giza, but Switzerland used this debris to create small artificial islands in Lake Lucerne. The 450-meter-long Sissy TBM alone consumed as much electricity as 20,000 homes. At the end of this video, I want to pay tribute to the 9 heroic workers who could never come out from inside the mountain due to various accidents. In their memory, a memorial has also been built at the entrance of the tunnel, so that the world can remember what the real price of this engineering marvel was. We hope you will also like and share this Algem TV video to the fullest. Thank you so much for your loving comments. See you in the next amazing video.